Hello everyone, I am Janak. I am excited to present my paper SegMango Early Deep Mango Yield Prediction based on flower segmentation and weather data. My co-author are Professor Charu Sharma and Professor Azimuddin Syed. So background, what is yield prediction? So yield prediction refers to the prediction of total measurable output produced by system over defined period or area, typically expressed as a quantity per unit, like fruit per tree or mass per hectare. What is mango yield prediction here? So mango yield prediction aims to estimate the final number of fruits at harvest using early seasonal indicators such as a flower and fruit-led information. Let's see what is the motivation and goal. Motivations are one is the automation need, also the feature availability like flower and fruits, and technical advancement, specifically advancement in the computer vision and the cameras, and the research gap main. So yield prediction estimation is typically performed near harvest. It's a late yield prediction, limiting the early planning. So our goal is to predict final mango yield early in the season during flowering itself. So let's see the dataset overview. So in dataset 2024 data was available from our prior work, and we collected additional dataset in the 2025 for this paper. We collected 8 images per tree from 8 different directions. Our resolution is 8000 plus 6000 pixel, and total we have 1248 images, 768 from 2024 data and 480 from 2025 data. About dataset annotation and pre-processing, annotation is done using YOLO V8 plus SAM with manual verification using CVAD. This pipeline was built up in our previous work. For weather features, we aggregated statistics between flowering and harvest visits. For scale handling, relative depth estimation using depth anything V2 model be done. So finally, as inputs, we have image, time gap, weather, and scale feature per sample. Now, yield prediction model, we use SegFormer as a feature extractor, which is based on our prior studies results. So in stage one, image-based mango count prediction is done. So approach one is based on the segmentation plus linear regression. So initially using SegFormer, we done segmentation, we generated segmentation maps, and then extracted feature using connected component analysis and given it to the regression model. In the approach to instead of generating segmentation map and getting features, we just directly use encoder to get the features. We use every full layer to get the final feature, and whatever feature we got, we directly given to the regression model and got the output. To fuse different modalities like weather, scale, and time with the image modality. Initially, we concatenated other modalities and then use this co-attention layer to fuse them. Initially, in the co-attention layer, we converted them in the same dimension, and using this W1 and W2 weighted summation is done. And after that, self-attention layer is used to fuse them and then pass it to the regression model to get the output for an image. In the stage two, it's a per tree mango count. For that, for the 8 different images, we generated this per image from the stage one, and we got eight output for that for 8 images, and we given those 8 output to the regression model to get the final output. In the experimental setup, we done 5-fold cross validation. We have a 992 image level samples, 672 sample from 2024 data, 320 sample for 2025 data. Here we done this 8 minus 1 visits because the final visit is considerable as our ground truth. Same in the 2025 data, final visit is considered as a ground. We use MAE, MSE, and R2 as a matrices because our output is a regression. In the results, initially we checked for a dummy where we just took the mean value of the training data as output. Then we use SegFormer plus linear regression. You can see the results is improved. Then SegMango B0 and SegMango B1. B0 and B1 is the model type of SegFormer. B0 is a lighter model and B1 is the more deeper model. And we were getting best results with the SegMango B1. Here you can see the comparison of the number of parameter and inference time. For a per tree, again, dummy regression initially used, then SegMango B0 and SegMango B1. Here you can see again with SegMango B1, we are getting the best results. As this is the multimodality fusion based technique, so in the application we check the what kind of contribution of different modalities in the final output. So initially dummy, then time weather, time scale, image time weather, image time scale, and image time weather scale, all of them. So here you can see the results, and we are getting best with all of them. Also, we check that what if we don't use the self-attention layer for attention fusion, then the results are relatively bad. In the conclusion, we improved time series vision dataset for a mango yield estimation. Also, a multimodal input-based yield prediction model we developed. In the future work, we can use UAV, UGV based automated data collection. We can improve the spatial fusion technique, 3D and 2D based, specifically for to fuse those 8 images per tree. We can extend this yield prediction to other fruit crops. This is the reference. Thank you.